In this video, we will discuss the rules of exponents, and in this case, integer exponents. So let's look at a first example. Let's start with the definition of b to the 0 power. So literally, anything to the 0 power is actually equal to 1. So b to the 0 power is 1. Let's look at another one. If we have b to the negative n power, so this is rule for negative exponents. So b to the negative n power. We really take the reciprocal of this. So look at this as 1 over b, the entire quantity raised to the positive n power. So notice I took the reciprocal of b and changed the exponent to a positive power. And then this final result is 1 over b. 1 over b. So that's 0 power and negative n power. Now let's look at if we had the example of b to the m power times b to the n power. Now in all these cases, our b is a non-zero real number here. So if we have b to the m times b to the end result is b. Notice my bases had to be the same to combine these. So b to the m plus n power. So in this particular case, you add your exponent. So let's look at an example of this guy. Let's look at an example. So what if we had x to the 3rd power times x to the 5th power? Here we would end up with x to the 3 plus 5, which is just x to the 8th power. So notice we had to add the exponents. Bases had to be the same and add the exponents. Now let's look at another one here. Another example for this guy. What if I had 2x squared times 3x to the 7th power. So notice here we have some numbers in front of our exponent. So here in this particular case, I want to take 2 and 3 and multiply that together in order to give me 6. And then notice we have x squared times x to the 7th. So x squared times x to the 7th, just like the step before, we want to say x to the 2 plus 7. So the final result for this is 6x to the 7 plus 2 is 9th power. So notice the difference here, we had numbers in front of our variables. And so here we multiplied the numbers, the integers, and then we multiplied the variables in this particular case. So one other rule that we want to look at is b to the m over b to the n. So that's the quotient power. What happens if I have a quotient? So in this particular case, we end up with b to the m minus n power. So the rule is if I'm dividing in this particular case, notice once again that my bases are the same, both b's. Now if they were different, if this was a b and that's an a, I wouldn't be able to combine this. So the bases must be the same. B to the m power divided by b to the n is equal to b to the m minus n. Now let's look at an example for this guy. An example here, if I had y to the 6th divided by y squared. Here, once again, because I have y over y, we can combine this and this will become y to the 6 minus 2, which would give me y to the 4th power. And that would be the final answer for this particular case here. Let's look at another one. What if we had, for example, 5x to the 9th power over 10x to the 3rd power. So what's going to happen here? I have 5x to the 9th power divided by 10x to the 3rd power. Well, here I want to simply reduce my fraction. Notice I have 5 over 10. I can reduce that fraction. 5 goes in the 10 2 times. And then we can use the rules for the exponent. So let's see what we would have here. In this particular case, I would I'm going to just draw my line here. I have x to the 9 minus 3. I just used the rule exactly like we did the step before. But however, I still have a 2 in the denominator, so I'm going to put that 2 there, So my final answer will be x to the 6th power, 9 minus 3, over 2. So that would be the final answer in that particular case. So now let's look at a power to a power rule. So this is power to a power. So if I have b to the m all raised to the nth power, in this particular situation, we want to multiply the exponents. So I end up with b to the m times n power. b to the m times n power. And let's look at an example here. If we had x to the 3rd power raised to the 4th power, here we would end up with x to the 3 times 4, which is x to the 12th power in that example. So that's power to power rule. And let's look at this other guy. What if I have a times b all raised to the mth power? So notice we have some parentheses here, and I have 2 things inside the parentheses, and that's all being raised to a power. In this situation, everything inside the parentheses must be raised to the mth power. So we want to write that as a to the m times b to the m. So note that everything inside the parentheses has been raised to the mth power. So our example that we want to look at is if I had 2x raised to the 3rd power. So 2x raised to the 3rd power. And once again, I want to break this down as 2 to the 3rd power times x to the 3rd power. Note that everything had to be raised to the 3rd power. And then I could clean this up and simplify it to be 2 to the 3rd power is simply 8. And then x to the 3rd power. Let's look at one other, just to make sure we got it. So another example of this guy. What if I had 5x squared, and I raised this whole entire guy to the 2nd power? So once again, everything inside must be raised to the 2nd power. So I will have 5 raised to the 2nd power, as well as x squared raised to the 2nd power. So now I have power to a power again, kind of using multiple rules here. But let's go ahead and finish this. This would be 5 squared, which is 25, and x squared raised to the 2nd power. What do you think that would be? Remember, we have to multiply these exponents, correct? So this is going to be x to the 2 times 2, so which will give me x to the 4th power as our final result for this particular problem. That's our final result. And lastly, the last one that we want to look at is if I had a over b all raised to the mth power. So a over b all raised to the nth power. So once again, what do you think is going to happen here? Remember, just like before, everything inside the parentheses must be raised to the mth power. So here I'll have a to the m over b to the m. So our examples that we want to look at for this particular guy, if I had 3 over x, and I want to raise all of this to the 2nd power. 3 over x all raised to the 2nd power. So here, once again, everybody needs to be raised to the 2nd power. So this will be 3 squared over x squared. So 3 squared, what is that? That's simply 9 over x squared. So as long as we remember that everything inside parentheses must be raised to that power, we could get that. So we'll try some more examples and see if we got these rules. But these were our basic rules for exponents. So you must learn these particular rules, so please practice these. Thank you.